As well as Kc calculations, we are sometimes asked to explain in terms of Kc what's going to happen to the composition of an equilibrium mixture if a factor is changed. Now, remember that the only thing that can change the value of Kc is temperature. So in the first one here, we're going to explain in terms of Kc what's going to happen to the equilibrium composition when the pressure of this equilibrium system is reduced. Now, before I go into this in terms of Kc treatment, I'm going to just think about in terms of AS with just Le Chatelier's principle. The reduction in pressure favours the side of the equilibrium with the most moles. So we know, hopefully from AS, that a reduction in pressure will send this equilibrium over to the left-hand side. The problem is that is not explained in terms of Kc. So we've got to give a slightly more complicated or complex explanation. So obviously Kc expression is required, and there it is for this system here. And we've got our concentration, equilibrium concentration of our products raised to the power 2 divided by the equilibrium concentration of the reactants squared because of the 2 there, and power 1 because there's no number balancing this in the equation. So what effect will this have on Kc? Remember, if the size of the volume of the container was doubled, the concentrations of everything is going to halve. So in this pink space here, this pink circle, what I've got here, these are the factors. So I'm not putting the actual concentration in, I'm putting the factor it will be changed by. So the new concentration will be half of what it was initially. And remember that that's going to be squared in the Kc expression. And essentially we've got half squared multiplied by a half, which is a half cubed. And so the upshot of that is the top part of the Kc expression will be a quarter of the size it was before the pressure was altered. And the bottom will be an eighth as big. So you can see straight away that these numbers are bigger than these are. Now the pressure is being changed. That will effectively knock this out of equilibrium because it's going to start to increase Kc. Now remember, Kc can't change because we're not changing the temperature. So the equilibrium has to respond to cancel out what you're doing. So a typical answer would be something like this. A decrease in pressure will lower the concentrations of everything. The bottom term in the Kc expression decreases more than the top term, and that's because of the powers involved in the top and the bottom. And so the system is no longer in equilibrium. To keep Kc constant, remember Kc can't change, the equilibrium has to shift to the left, i.e. the NO will dissociate more to restore Kc. So in other words, the composition of the equilibrium will be that the concentration of the reactants will increase because the equilibrium is going this way. The concentration of the reactants will increase and the products will decrease until the equilibrium is restored. So we'll look at this one now. Explain in terms of Kc what happens to the equilibrium composition when the pressure is increased now. So if you want to have a think about this, pause the video and then I'll go through the answers with you. So suppose the volume of the container is halved. All of the concentrations now are going to double. There's the Kc expression. So we'll look at the factors now. So the top will double to the power 2. The bottom will double to the power 1. So which which part of the Kc expression is affected more? It's obviously the top. So there's a bigger box on the top now compared to the bottom. That means Kc is going to effectively start to increase. It's not allowed to increase because we're not changing the temperature. So how will the system respond? The pressure increase will increase the concentrations of everything. The top term in the Kc expression increases more than the bottom term. System is no longer in equilibrium. Remember, that's because of the powers. So the equilibrium shifts to the left, i.e. the NO2 will dissociate more to restore Kc. In other words, the concentration of the reactants will increase and the product will decrease. So that's the exact same answer we gave in the previous scenario. And what I forgot to say was the AS answer to this would be an increase in pressure favours the side with the fewest moles. That side's got the least moles, and so this equilibrium will go that way, but that's not explained in terms of Kc. The last one, in terms of Kc, what happens to the equilibrium composition when the pressure of this is increased? So we've got H2 and I2 in equilibrium with 2HI. So again, half in the size of the container, which is double the concentration of everything. There's the Kc expression. I'm sure you can appreciate what's going to happen. Or you could think about it in terms of AS first. So what's going to be the effect on Kc? The factor is this doubling squared on the top, and that's going to double times double, so double squared again. So in other words, there's going to be no difference on the Kc expression once you include the factor. And so the increase in pressure will increase the concentrations of everything. Both terms in the Kc expression are affected equally now. So Kc won't change. This system is not knocked out of equilibrium, and so it doesn't need to shift. And so the equilibrium concentrations remain the same. So I hope that's cleared things up for you, because I've had a few messages on YouTube to see if I can explain that in a simple way. It's not a particularly simple concept, but I hope that's helped.